I can't actually see the participant count, but are we still, is it still going up?
We're at 10 right now.
Okay.
Yeah, looks like it's kind of slowed down now.
Okay. Well, maybe we can go ahead and get started. So welcome everybody to this Gauge Sage Special Interest Group session, providing an update on the Rapid Response to Geohazards initiative. My name is Justin Sweet, and along with Kent Anderson, we are going to be your presenters today. And I want, I'll do introductions here in just a moment, but before we get into the session, I just want to remind everybody of some general Zoom etiquette. So please make sure that your real name is showing up in the participant list. So if you do have a question or raise your hand, we know who we're speaking to. I'd like to ask everybody to please keep your microphones muted during the session. We will have time for Q&A at the end of the SIG today, and at that point, we'll call on you one by one, and if folks want to unmute at that point and ask questions, they can. Just other general stuff, you probably don't need your video running during the presentation period. We encourage you to mute things and limit distractions. And as far as questions, we would encourage you to please use the chat box on the virtual meeting page for today's SIG. If you have any questions during the presentation, you're welcome to type those in there, and we'll make sure to circle back on those during the Q&A period. The point of doing it here in that chat box is that it will be preserved, and then if there are other participants who come in later or who want to watch the recording later, they can see some of the questions that were asked. And finally, then, before we get started, just some general points. We want to make sure everybody's being respectful and considerate of a diversity of viewpoints and opinions that are here today. So just please remember to be considerate, inclusive, respectful, and approach things in a collaborative spirit. Okay, so I do want to take a moment to acknowledge and recognize my team here that's been helping to drive this Rapid Response Initiative forward, starting with Ann Meltzer, who is our community representative from Lehigh University, also Bob Woodward of IRIS, Kent, and then myself, also of IRIS. And as I mentioned at the beginning, Kent and I will be speaking and leading today's SIG session.
Yeah, and as Bex has already pointed out, something happened in the week since that photo was taken of me, and my hair's gone white. Same with Bob Woodward. Maybe we could update those photos, but it's been a rough week.
All right. Well, let's get started then with just an articulation of the goal for today's SIG. So our goal is to provide all of you and the larger community with an update on the status of the Rapid Response to Geohazards project, as well as offer an opportunity for the community to ask questions and get answers. And as I mentioned, we will have a Q&A session at the end of today's SIG. So here is an outline of our agenda for today. We're going to start off with some introductory remarks. We'll review the project timeline, discuss the recently released Rapid Response white paper. We'll talk about some facility recommendations and guidance and approval from community governance. We'll discuss the ongoing instrument testing that's taking place as part of Rapid Response at Pascal. And then finally, we will outline some of our upcoming milestones and then get into the Q&A session. So first, some context for this effort. The need for an enhanced rapid response capability was articulated by the community within the successful SAGE 2 proposal. That proposal was funded by NSF, and as part of that proposal, approximately $1 million was budgeted towards the rapid response effort over the 5-year duration of the award. Most of that money was programmed towards the procurement of new rapid response instrumentation. And the goal of the effort was to develop a dedicated rapid response capability that was specifically based on community requirements.
I might add.
Oh, yeah, please go ahead, Ken.
Sorry, I might add that this was kind of coordinated with the UNAVCO gauge proposal as well, to try to have a multidisciplinary rapid response capability. The SAGE portion of this was funded, the gauge portion was not, but we continue to coordinate, as Justin will refer to later, with all the disciplines on what the future facility might go towards. Also, just one comment on the 5-year effort of this. There was some time phasing required on this to push it towards the later half of the SAGE award to allow us to procure more instruments on the Wayfield portion of this program first. So that's why it's kind of phased towards later. And we'll talk about the timeline here in just a minute.
Thank you, Ken. Yep, good points. So just a little bit of background. So why is a rapid response capability needed? I would be remiss if I didn't acknowledge the fact that the Iris-Pascal Instrument Center has supported rapid response needs of the community on an ad hoc basis for many years, and that support continues to this day. The issue is that the current dedicated pool of rapid response equipment is pretty small. It's only about 10 sensors, and those sensors are decades old and not really appropriate for the demonstrated use cases from our community. Nowadays, the latest generation instrumentation that's available on the market is much smaller, lighter, and significantly easier to deploy, particularly direct bury instrumentation that completely negates the need for expensive vault construction to hold the sensors. So you can just bury these direct bury sensors right in the ground. And that saves our PIs critical time and money, especially during high pressure rapid response deployments. So the general plan for this effort is, again, with the goal of developing a dedicated rapid response capability based on community requirements. So our first step was to make sure to capture those community requirements, the needs of the community for doing their rapid response science. Step 2 was to digest that information into a community document, which is what is released as the white paper. And that document was important for that document to prioritize the rapid response capabilities in accordance with the available funding for this project. And then the last stage of the project, as Kent mentioned, is moving into the actual instrumentation phase. So beginning with some testing and evaluation, and then followed on with instrument procurement and implementation. So here's a rough diagram of the timeline for this project. And you can see that as of today, where we stand in 2021, we are nearing the end of the technology survey and evaluation phase, and we are moving right on into the procurement, integration, and deployment phase that is anticipated to wrap up in 2023. Just want to stop and highlight a couple major milestones or progress marks along the way thus far. So 2019 was really dedicated to an extensive period of gathering community input. We did that through a special interest group meeting at that year's SSA. We also had 6 community-led virtual breakout sessions focused on a variety of rapid response topics that provided a lot of really helpful input. And IRIS hosted a rapid response mini workshop adjacent to that year's SAGE Gauge meeting. In 2021, we took all of that community input that had been gathered and synthesized it into a white paper that was released last fall, so in the fall of 2020. And as I mentioned earlier, that white paper crucially contained recommendations on prioritization of capabilities to meet the articulated science goals of the community. This year, using that white paper guidance, we have selected and procured a small number of test units for testing and evaluation and consideration for the final procurement pool for this equipment pool. And as of today, the project is currently on track and set to begin instrumentation procurements as soon as later this year, and then continuing as well into 2022. So next, I want to just go into a little bit more detail on what was recommended in the white paper. And Kent, feel free to jump in too if you've got comments. Don't hesitate to stop me here. So rapid response science needs. So as I mentioned, over the past several years, we had an extensive period of collecting feedback from the community on their rapid response science needs. And that also included specifically community-led virtual breakout sessions. And I wanted to make sure to highlight this here because I want everybody to know that recordings and presentations from those virtual events have all been archived and are available for viewing on the IRIS Rapid Response webpage, which you can see the URL listed here on the slide. I also want to acknowledge, as Kent mentioned at the beginning, that that geodetic data is a key component of many rapid response deployments. And so IRIS has throughout this entire process has been working closely with the Gauge facility and UNAVCO to make sure to incorporate geodetic capabilities as part of our rapid response deployments looking towards the future. So the Rapid Response Community White Paper, this was, as I mentioned, a result of compiling all of the feedback that we collected. And if you'd like to grab a copy of that white paper, that's also up on our website. I think I've also placed a copy of it on the Pathable page for today's SIG under the Files tab, if you'd like to grab a copy and review that. So in addition to discussing the rapid response science and needed capabilities, much of which was articulated in our community listening sessions, this document also includes short-term recommendations for instrument procurements with existing funds, as well as longer-term recommendations for capabilities that will require ongoing future funding support. And I guess I would just note that, as you can imagine, when we put out the ask to the community of what do you want to do your rapid response science, we got a ton of feedback, and there's a lot of really great ideas. We covered everything from geodetic capabilities to magnetotellurics, ocean bottom rapid deployments. I think there was a geomagnetic component as well. So there was a lot of great science and needed capabilities that we heard about, and those are all included and articulated in the white paper. Unfortunately, not all of them are able to be addressed with the pool of funds that are available for this project. And so we may think it's important to still capture all those community science needs, even though we're not going to be able to necessarily address all of them today with the funds available.
Yeah, I just want to add some real quickly. If you all listen to Ramon Earthsmith's talk on the portfolio review, it's very encouraging to see that that panel is also recommending some of these longer term recommendations that I think the community has kind of put in towards this white paper on rapid response, because that panel was recommending a large set of multidisciplinary rapid response instrument tools, and I think this document is a good source to start moving in that direction. As Justin mentioned, with the limitation of funds, I think we have enough to kind of get the seismic side started, maybe some strong motion and infrasound as well, but we'll get into that in a moment. But I think this document will have some longer legs to it, I hope.
Yep, great point, Kent, and that's a good segue, because the next section here, I just wanted to make sure to go through and articulate some of the specific recommendations that were included in the white paper. So these are recommended instrumentation capabilities based on the available funds for this particular project. So specifically here, the white paper recommended under direct buried 3-component seismic sensors, something in the neighborhood of 10 broadband sensors, 30 compact broadband sensors, about 200 nodal sensors, and 10 accelerometers. In addition to that, they recommended some about 40 latest generation telemetry capable digitizers, roughly 10 infrasound sensors, and then again about 40 quick deploy boxes that are purpose built and designed for this equipment with batteries and solar panels ready to roll, so that we can get this equipment out in the field on a moment's notice. And I would just comment here that the quantities and types of instrumentation that are listed here were based directly on both a prioritization of needed capabilities based on the community's articulated needs, but also based on the funding available. So that's how we arrived at these numbers. It's based on what was the community asking us for in a prioritized sense, and then how much money did we have available to try and meet those needs. In all cases, it was strongly recommended, the white paper strongly recommended evaluation criteria, including the prioritization of small, lightweight, easy to deploy systems with minimal power needs. So next, we're going to move into some discussion of facility recommendations, as well as guidance and approval from community governance. And for this section, I'm going to hand the microphone over to Kent.
Great, thanks, Justin. Yeah, just to be clear on that, we are working closely with the IRIS governance, as we do on all projects, to make sure that this is truly meeting the needs of the white paper to the best of our ability. However, it's the technical role of the facility staff to make sure that the options are available, technically feasible and sustainable. So we're kind of looking through the recommendations from the white paper, seeing what fits best into the operational modes at Pascal, what is sustainable and supportable in the long term, and at the same time meeting the overall needs of the community in terms of being capable for rapid response deployments. So in terms of the broadband sensor systems, really key to emphasize the logistics effort, the size, weight, and power configuration of this to ease the actual installations in the field. And so a lot of the criteria that we're searching for is not only the broadband functionality of, I think this slide changed a little bit there, the broadband sensitivity of the instrumentation, but also the deployability and logistics requirements for these systems at the same time. We have made some suggestions that allow us to get a larger number of broadband systems by not segregating between short period and broadbands, but just looking at small, compact broadband systems as a whole to kind of maximize the uniformity and the configuration management of this broadband pool. So we'll go into that in just a moment in terms of what we're currently looking at. In regards to the nodal systems, as those of you who know node systems, we do have a couple different varieties that we are using at the Instrument Center. There are also types of nodes out there that kind of incorporate some next generation technologies in terms of communications topologies and point-to-point communications. I think one of our concerns is that we're if we spend all that money on that communication technology, it's not going to leave us many instruments. So at this point, we decided, the facility recommendation is to continue to stick with expanding the nodal pool, for which we already have infrastructure at the Instrument Center, and that allows us to not only manage configuration control better, but open up access to a broader number of instruments from the standard pool as well. In terms of infrasound sensor, this is relatively new to us, although in the TA and then also up on Mount Erebus, we are deploying some infrasound sensors. We don't have money for a great deal of these, but we are trying to coordinate with the groups at Converse and working with USGS on different types of acceptable infrasound sensors. And with the small numbers that we will have, we're looking at these higher class types of instruments from Chaparral and Hyperion. There are smaller, lighter weight MEMS type systems out there that may be not as capable at this point, but they're under development. So as we look to expand the pool with infrasound, we might go in a direction that kind of lives up to this small, low logistics lightweight systems, as long as they are technically capable as well. Next slide, please. Telemetry. This is always a hot topic. Telemetry in terms of how it could be used in a rapid response. It kind of speaks to the difference between, are we setting up monitoring systems for hazards, or are we setting up science instruments and tools for hazards? This is another cost consideration that the facility staff have been mulling over, in that if we go into telemetry solutions, it will greatly reduce the number of actual sensors we can put into our pool, and we'll have to maintain those costs for telemetry systems. So at this point, at this stage, in the beginning of this new growth of the pool, we're looking at keeping telemetry solutions in mind, but not emphasizing the telemetry aspects of it at this point, just so we can get more systems out there and keep that in mind as we grow the pool and add diverse types of systems in it that may require telemetry capabilities. But for now, that's how we're going to make recommendations to governance to address the white paper concerns. Next slide, please. Governance oversight. As I mentioned, all IRIS SAGE facilities have governance oversight, community oversight. And so as part of our technical evaluation of systems that will meet these goals are assessed by the facility staff, we'll be making presentations to our governance oversight committee. As Justin mentioned, we had a tremendous amount of community input, but when it comes to actually making giving guidance on procurement decisions and ongoing maintenance of the systems, that will fall to the Pascal Standing Committee. So we will make our final procurement recommendations for this pool to them this fall, and with the go-ahead, we'll actually start procuring instruments immediately. So as soon as instruments are delivered, we'll be evaluated, and we can move on to the next level of getting these out in the field. They were also, the governance oversight also has a approval authority on the policies for the usage of these instruments. And so we're currently drafting how this pool is to be used, kind of the rules and regulations of what constitutes dipping into this rapid response pool. And we'll be reviewing that with our governance as well to make sure that's appropriate to the white paper recommendations. I think that was my last slide.
Yep. Thanks, Kent.
Sure.
All right. I'll go ahead and take over the next section here and just touch on some of the ongoing instrument testing that's taking place right now at Pascal. So this summer, the facility has received and begun to test small evaluation sets of sensors for consideration in the rapid response pool. I've got a picture here on the right of some of those sensors. For this testing, we selected small direct bury sensors from 3 different manufacturers, and this form factor minimizes logistics for rapid response deployments. So as we've mentioned earlier, we really were focusing on this small, lightweight, low power, easy to deploy form factor. So in addition to basic functional tests, Pascal technicians are putting these new sensors on our piers and testing them to compare their response and noise performance relative to the other sensors. We're expecting to have these sensor evaluations complete sometime this fall, after which, as Kent mentioned, a recommendation will be forwarded to the Pascal Standing Committee for them to deliberate on and modify if desired, and then approve. Okay, so that is a nice segue into kind of some upcoming milestones. So this fall, as I mentioned, the community governance, the Pascal Standing Committee is going to review and approve of a procurement plan for the new rapid response instrumentation pool. And as soon as we've got that plan approved, we'll go ahead and get started with our procurements. Those procurements will continue into 2022, followed by acceptance testing as that equipment is received at the facility, and then integration into existing facility systems. I think Kent also touched on this, but in the year ahead, we'll be working diligently with our community governance on the development of policies and procedures for usage of this new rapid response capability. And then 2023 is when we're targeting full implementation and availability of this new set of rapid response equipment. So with that, I think we have finished all of our presentations, and we can move on into the question and answers section. So for folks out there, there's a couple ways for you to ask questions. Of course, we've got the chat box available up on the platform Pathable meeting page for this particular SIG. You're welcome to type your questions in there. Folks are also welcome to use the raise hand feature here within Zoom. I think that's under the reactions section. If you move your mouse, you should have a little menu, and you can click on reactions on the bottom of the screen and raise your hand. We'd be happy to call on folks one at a time, and people can unmute and ask their questions. I've got my email address up here. You're always welcome to fire off an email. And of course, the Rapid Response webpage link is on there as well, which is a great resource for information about the project, as well as contact info if you have questions. So I don't actually see the Zoom question thing, but if anyone has their hand raised, Kent or Kristen, maybe you can direct
or just speak up.
Or just speak up. I don't see any questions out on the main page, but I will.
There we go. Bix is volunteering.
All right.
Okay, I'm gonna start with a question. I was wondering if we had an idea. So this is a pool that is going to go into the field for rapid response for a variety of events. And often in the community, there are people that have already instruments, and there are other, universities or other federal agency that have already instruments available. Do we know how this pool will merge with that pool, if these are instrumentations that somehow are complementing them, or they're completely new, or how do these different pools come together in a overall vision of serving the community when an earthquake happens, for example?
Sure. I'm happy to take a stab at that. I think when a large event happens, actually, as we've just seen with the Haiti event last weekend, there is a tremendous amount of coordination of activities and looking at resources that are available to try to make sure that not only the right equipment are getting at the right place at the right time to measure the right thing, but we're not overwhelming logistics resources. So certainly configuration management is an important part of that. We can't control who all is going to be installing what for every event, but we are trying to look at configuration management within the Pascal Instrument Center, such that as things are used, they're not totally alien relative to the other types of instruments that the Instrument Center currently serves. So we're not trying to even cross ourselves up, but we're trying to make things such that they're compatible. Does that answer your question?
Yeah.
Okay. I might also add as well, relative to that, there's always this tricky part that we face with our rapid deployments that turn into long-term experiments. I mean, because of course something happens once in an area, it's always going to happen there for years and years. So this is one of the struggles that we'll have with the policy, is to make sure if something is is transitioning from a kind of a rapid experiment such that we can get immediate data right away, we don't want to lose that equipment for a long-term experiment. So we'll be considering in our policy how to transition those into a longer term, more normal Pascal experiment and get those resources back to the instrument center such that they can be available for another use.
I have another question, but I don't want to maybe.
It looks like we did have a question come in on the chat box, so maybe I'll go there, Bix, and then we can come back to you.
Yeah.
So so Alexander was asking, what is a target timeline for the rapid response program is trying to achieve from receiving a request to actually having instruments deployed, and what significant bottlenecks exist? And that's a great question. The process of actually getting this equipment out in the field after an event happens is not simple. It can be rather complicated, and this is exactly exactly the kinds of questions that we're currently wrestling with, that are going to be articulated in the policy documentation that we're working on to try and streamline that as much as possible, so that we can maximize the availability of equipment in the field as soon as possible after an experiment happens.
If I might add, Noel, I saw you unmuted, so I'm sure you have comments. Well, I just want to start off saying the initial part of the response, if you want to use the pool, immediately contact the Pascal Instrument Center, and I think you'll see a very quick turnaround on our response to it. I think there still are some bottlenecks associated with getting funding through the rapid funding through NSF, or if you have your own funding, that's not a limitation. But depends on where you're going. There are limitations associated with import export of cargo, and particularly dangerous goods, particularly with the nodal systems and the lithium batteries. So those are a couple of bottlenecks that we deal with. That said, I mean, the recent Alaskan earthquake, the Pascal Instrument Center team was able to get instruments in the hands of PIs within a couple of days of the request, and so I think that was impressive. Noel, did you want to add to that?
Well, actually, you were breaking up. My internet isn't that great, so I don't know if everybody heard what you said, but I didn't hear everything you said. The big bottleneck is the funding, and often when we get a request for rapid, it's not for 100 instruments. It's enough that we can get it packed up and ready to go in a day, but we can't ship it until somebody is funded to cover that shipment. And we've asked IRIS to have some sort of slush fund that they could, front the money for the shipment so that the rapid stuff could get in the field rapidly. But that's not going to happen. So what I'm thinking is, if you think you might want to do a rapid, if you could possibly arrange with your department to have possibly some funds ready for something like this, that would be ideal. And in this Alaska one of the PIs said, yeah, my department can cover the shipment out to the field. So then we could go ahead. Not everybody can say that, though. I think it's a big weakness of the whole rapid concept. We want to get it out the door the next day. Where's the money to do that?
Yeah, that's a good point, Noel. I think funding certainly is one of the major bottlenecks that comes with these rapid response requests that come in. And as you said, the facility is pretty good about responding to those in a very timely manner. But we have to have funding in place to enable the shipment of those sensors and associated equipment to the field. So certainly, if folks have department funding or internal funds they can rely on, often that's a quicker avenue than having to submit a rapid proposal to NSF.
Certainly, though, that is important. If you are applying to rapid, get in contact with the program officers immediately as well. And if they may give us a go ahead to say, yeah, this is pretty certain to be funded, they might kind of allow us some pre-award authorization, or at least will reduce the risk that Iris would have to take these on.
Yeah, actually, this Alaska, after the Alaska earthquake, was the only one I remember where NSF Rapid gave immediately a very strong, yeah, I think we'll fund this. Usually it comes much later. The maybe, not even the yes is even much later. But I guess that was the biggest earthquake since 1965 in the United States. So I guess NSF thought that was pretty important.
Thanks for bringing that point up, Alexander. I think that's an important part of this process, is not only having the equipment, but the funds in place to turn that around rapidly. And certainly, I think, as you mentioned, it's really important to get that out there as soon as possible, but within reality, unfortunately.
I guess it's also good. I mean, I know we have a pretty seismic centric group here today, I would guess, but it's also important to remember that, we're not just talking about using this pool for responding to large, aftershocks from large earthquakes, but there are other types of geohazards like volcanic unrest, landslides, things like that can have different timing needs. In particular, with volcanic unrest, oftentimes you can get out there before the eruption even occurs to try and collect some data there, so that hopefully you can actually catch the main event as it's happening. So depending on the geohazard you're going after, some of the timelines can be a little bit different. So I can't see if we've got any other hands raised, but I know Bix, you said you had another question. I don't know if you wanted to
I guess,
and raise that.
Yeah, I mean, if there are no other questions, I might ask my questions, which is still on the, this is a great opportunity, the way, obviously is provided to the community. And I see that in order to get the biggest bang for the buck, the community wants to coordinate this with the existing efforts whenever an earthquake happens. And so for these coordinated deployments, obviously, we want to, they require that the data also be located often in the same place to take advantage of these opportunities, right? So I wonder if there is the policy of how to store the data that comes from this, from these deployments versus the other deployments that happen, from other entities, is going to be defined in the policy that are still to come, or is somehow described somewhere else, or is still something that needs to be defined, or
So I mean,
if there's any decisions about that, because I think it's an important part that the community should be aware, or have a voice, or have had a voice, or or can we have a discussion about that?
Certainly, I think it is understanding our intent to make sure that these data from the NSF held SAGE equipment is immediately and openly available. Now it depends on what other partners we're working with and who we're collaborating with, and what their limitations are on other equipment set that will also be committing to this, whether they will openly share data immediately as well. So that's always a tricky part, but I think that can help drive our deployment models as well, as if we know we're collaborating with an agency, but they're not going to share their data. It might change how you design the array such that you get the immediate needs that you need to assess this geohazard. And if there's redundancy, maybe it's worth it for the sake of immediacy of access to the data.
Right. I think that also having the data shared in the same place, like all in the DMC, for example, would be useful for the entire deployment. I'm thinking about Ridgecrest. That was a great example of how the entire data set collected by a variety of entities was all stored in the same place.
And I think for the most part, I think that's going to be the intent. But of course, it's always event specific depending where it happens. Haiti is an interesting example as well, where there's several different international organizations trying to respond to this at the same time, each with their own policies. And so I think eventually it'll be open, but in terms of how soon, and number one, how soon it can be deployed, but how soon the data will be open are things that might be slightly beyond our control, but certainly by continuing these international collaborations, we'll have some influence on how we'd like to share data. So thanks for that.
Any other questions from the group? Again, you're welcome to use the chat box to type in a question, or if folks want to raise their hand, we're happy to call on people.
Otherwise, thanks for the briefing, Justin. And I think it was intended just to be brief. And so maybe we can let this go and allow people to attend some of the other interesting SIGs that are happening right now.
Yeah, if there are no other questions, yeah, maybe we'll wrap early. Just want to make sure to thank everybody for tuning in today. I know that some of this, I think this session is being recorded, so there may be folks tuning into this kind of after the fact. Again, please don't hesitate to reach out via email or via the IRIS Rapid Response webpage if you've got questions or need additional information or are interested in the project. We'd love to hear from you.
Richard, go ahead.
Yeah, I saw Richard Boaz had one quick question here.
Oh, sure.
And this was on the chat. How quickly will the data be available after instrument network deployment? It's our intent, and of course, this is going to be defined in the policy, but our intent will be, if you're going to use this pool, the data have to be immediately openly available, depending on how the data can get back. In some cases, like node instruments, you have to wait till the instruments are recovered to get the data back, but we'll try to get it back as soon as possible. If there are opportunities to share telemetry, we will argue that whoever's providing the telemetry make that available in real time. Does that
Great.
answer your question, Richard? Okay, we'll assume yes.
Hopefully so.
Okay.
Yeah. Okay. Cool. Great. Well, thanks again, everybody, for tuning in. Appreciate you being here. And again, if you've got additional questions, please don't hesitate to reach out.
Cool. Thanks, everybody.
Thank you.
Thanks all.
Have a great rest of the workshop.